Let's now talk about equality. Since we are doing object-oriented design, so we should really be clear about how to define object equality among the same type of objects, as opposed to compare them just by their addresses. The way object equality works is not exactly the same as IFO. However, for the differences, I wouldn't want to discuss them in detail in this at this level of the introductory tutorial. I'll just tell you the best practice for you to do, so that'd be more straightforward for you to complete your exercises for your labs and for your projects. Okay, so let's move on to the birthday class over here. Like in Java, if you want to override the equals method, you have to override it, right, by providing a new version. However, in IFO, if you want to redefine, we call redefine. If you want to redefine a particular, let's say, is equal query, you have to explicitly say that. Okay, what do I mean? And every time you want to redefine a particular feature, remember in the previous post condition test, if you want to redefine the make command from the birthday class, you had to say inherits birthday redefine make. That's what we said. So now, if you want to redefine the is equal query from the any class, you got to say that too. Any class is like the object class in Java. Okay, so we'd say inherits. Okay, actually, let me put the indentation right. So it's birthday inherits any over here. Basically, every class in IFO inherits from the any class. It's like every class in Java inherits from the object class. So any, and then we say redefine, and then here we say is underscore equal. You gotta spell it right verbatim, and end. Again, you can have as many features as you that you want to redefine, just separate it by comma if you wish. Okay, but for now just one. And as soon as you compile, the compiler is going to say you already claim that you want to redefine is equal, but you haven't declared that. You haven't redefined that. So that's why we're going to do it. Okay, that's why in the very beginning of the tutorial series, I created this equality section over here, and now we want to redefine that. Okay, but now what should be the header or signature of the is equal? We want to be consistent with what's inherited. So I would suggest, let's open a new tab. Let's go to the any class, ANY. So that's the top class at the hierarchy for it's a superclass of every class. And let's go to the is equal feature or query specifically. Okay, that's the header we want to copy and then paste. Notice one thing. The implementation for is equal by default. In the case of Java, for the equals method in object class, you simply say this equals obj, right? Just saying by reference equality by default. However, for IFO, it's doing something that's built in, which is not exactly like the default behavior for Java. That's why for this part here, I don't want to get into it. I would say every time you want to compare your objects by contents, you should explicitly redefine the is equal query, and then the behavior about the dynamic binding will just be the same as what's in Java. Okay, that's what I would recommend. Okay, so now this is built in. Okay, we are not worried. So now just copy the header, and like current is something called anchor type, which I will explain at the end of the video. Let me finish the programming together with you first. Let me copy this header over here. Control C to copy it. Let's go back to birthday here. Let me declare that. Okay, and then let's say do. Okay, very briefly speaking, current is referring to, it's like a this, is referring to the current class. What's the current class? The current class is birthday over here. So let me so birthday here. So when I say over here under equality, when I say like current, it is as if I said other is of type birthday. Let me explain this here very quickly. Like is called the anchor type, which means it's going to correspond to another type that's defined elsewhere. Okay. Okay. Here, others type is. Others type anchors corresponds to the type of current. The current class, which is birthday. So it's as if we declare other over here of type birthday over here. So this one here is actually very different from what's in Java, which I will show you explicitly. But remember in Java, what's the header for equals method in the object class? It would be obj and then of type objects, right? Rather than of that particular class you're talking about right now. So that's a difference over there. So I'll show you in a moment. So now, knowing that other is going to be of type birthday already, so we don't need to check any about the dynamic type to do any casting, okay? So what we can do is we can assuming that so now assuming that other is simply of type birthday, how do we compare to birthday? Well, easy. We'll simply say so now because it's a Boolean query over here, so we can say we can reassign the result to be the desired result. We can say result is assigned to current.this, for example. Current.month equals other.month, and also conjunction. You don't need to say current over here because month is actually quite unambiguous. Okay, and also day equals other.day. Okay, that's it. This is part of what you will have to write if you try to override the equals method in Java. However, in Java you have to write much more. I will compare that at the end. Let's just make sure everything works. And then I'll say compile over here. Okay. So now let me just go to the test over here, test-driven developments. Let's test it. If I go to test birthday over here, let me go to the section for Boolean tests. Let me go to the end. Okay, right, maybe right after this comment here. Let's say T. Okay, let me maximize it. So T, let's say test for birthday equality. And then let's put the comments over here always. And then we can say over here T. Okay, let me copy and paste the query name. Oh, so now we are doing a Boolean query because now we want to see the expected result. In this case, we are using a Boolean test query because we are not expecting any violation, either precondition or postcondition to occur. So that's why it should be a back to Boolean query. Okay, so that should be Boolean. Okay, that's the so whenever you're wondering whether you should make a Boolean query test or a command violation test, think about if you expect some violation to be triggered. If yes, then you do the violation test. Otherwise, you do Boolean test. Okay, let's copy this name over here, and then let me paste it verbatim. And then test reference and object equalities of birthdays. Okay, and then I'm going to manipulate several objects of type birthday. Okay, if you want to declare several variable of the same type, you can put it in the same line. Okay, so you can say bd1, comma bd2, and then of type birthday. Okay, that's spelled wrong. Okay, let's make sure everything compile. Okay, sometimes it doesn't really show blue, but that's okay. Let's just continue. Okay, so now let's create, first of all, if I say, let's compare addresses first, just to warm up quickly. So I can say create bd1 dot make. So let's say October 15th. And then creates bd2 dot make. And then also October 15th. Even though their contents are the same, but their addresses are different because they were created using two different create instructions. So let's make sure they are different objects. Different objects, so they got different addresses. So I can say over here, result over here is a Boolean, is a Boolean, right? Result is a Boolean. Is reassigned to let's say bd1 equals bd2. So what do we expect to see? It should be false. But if you simply reassign false to result, then the whole test is going to fail because result should be true at the end, right? So what we can do is you can say not equal to. Okay, maybe I haven't shown you this, but it might be nice to show. Okay, so this will be okay. So that means this will be actually true, and then you will be assigned to result. Okay, because they're different addresses. Okay, let's make sure we actually include this particular query into the test case execution. Right? Let's go back to the make of the test birthday, and then we'll say add Boolean case agent and then that particular query, and then compile. Make sure, let's say run workbench system over here. Okay, everything works. So now you can see for equality, that one passed. Okay, let's now do a little bit about equality here. Since we have already redefined the isEqual query for our birthday. So now different objects, right? So now I want to write another reassignment. So I gotta say assign intermediate assertion, right? We covered that already. Okay, so now how do we compare objects? So I can let's do the way that's familiar to you. So you can say result is assigned to, let's say bd1 dot is equal bd2, right? And then this one here should be true, right? Because 10 and 15, right? 10 and 10, 15 and 15. Okay, so that should be true. And now if I simply run workbench system, I still get true. Okay, so nothing difficult here. Okay, one exercise for you: set a breakpoint over here, around here, and then step into it and see which version of the isEqual is being called. Is it this version of the isEqual that's being called, or it is this version that's default from the any class that's being called? So that's one exercise for you. I'll do something very similar together with you so that you can also do the exercise yourself. Okay, let's for test birthday. Let's still say check result, and I want to show you one more thing before I get to anchor type. So this very useful operator that you can learn. It's called the Telde Operator. Okay, basically I can simply say result rather than saying as a query call. It's assigned to, I can say bd1 Telde bd2. Effectively, when you say bd1 Telde bd2, it's as if you say bd1 dot is equal bd2. It's as if, given that you have already redefined the isEqual. So the Telde will actually do a content comparison. Okay, but if you want to say not equal to, you will simply say / over here, not equal to. Okay, so in this case it should be equal to. So now should it be true? In this case it should be true, right? Because they have the same contents, right? So now if I say run workbench system here, I still get a green bar. Okay, very good. So now I want to just set a breakpoint together with you and just to see. Okay, so now let me double click on the tab, and now let me highlight it, right click to drag and drop it to the feature over here. Okay, feature tab. Make sure you select the feature tab. So now let me simply put a breakpoint. Over here, test birthday equality. Did I compile? Let me just say compile here. Okay, let me compile first. And then if I drag and drop. Okay, sorry, I forgot to compile. That's why it didn't show. Let me just rerun the test anyway, just to make sure. Okay, you still pass. Good. Okay, so now let's set a breakpoint over here. What I want to do is I want to step into the Telde and see what actually happened. Because it's as if I call it isEqual, so you should really go to the isEqual. Let's just verify that. So now if I say run, and then we're gonna see it's gonna pause at a breakpoint. You can see the breakpoint is exactly over here. Okay, so now I want to step into the execution of this Telde operator to see exactly what's being executed. Okay, so let's do the step into the which we have done maybe a few times already. So let's say step into it. So now you can see that's the isEqual from the birthday class, right? So this should really be consistent with your understanding about the equals method in Java, because we have redefined or have overridden the version of isEqual that's inherited from any. So that's why when we say Telde, it's as if we call isEqual. So that's why we're going to this particular specialized version over here. Okay, so that's calling to compare month and day. Okay, that's something I want to say. So the most important message from this test case over here is like this. Of course, you should still be aware of whether you're comparing references for objects. That one is the same as Java. And now I would say always make sure if you have a particular class that you define yourself that you think you might want to compare the contents, always redefine the isEqual query for that. That's inherited from the any class. That's the syntax you have to get right. You want to say I inherit from any class and I want to redefine specifically its isEqual query. Okay, and then finally over here, if rather than writing this, which is completely fine, if you felt it a little bit too troublesome to make the query call, you can simply use a tilde. When you use tilde between two objects, it's as if you try to call the is equal between them. So assuming that the is equal has been redefined, it's going to call the customized version. Okay. One final detail I would like to mention, which is about, if I go back to the birthday over here, remember the header that I promised that I will explain. So let me just go back to the birthday class. Let me just compile so I can see the features update over here. So if I go to is equal, you can see this header over here is exactly the same as if I go to any class, it's also like current, exactly the same. I just copy and paste. Let me switch to my iPad. Let me compare how the equality, customized equality is done in Java. First of all, let's go to Java. Just review a little bit for you, just in case you have forgotten. In the case of Java, you can see the top level, we got the object class over here, right? And for the equals method here, the argument is always of type objects. So this is important detail to note. I'm going to compare with how things are done in IFO in just a moment. And then the way they implement it by default is simply just compare by references. However, in the case of IFO, they made it quite a secret to us. They simply say built in. If you pay attention to the any here, you can see it simply say built in. So let's not worry about what exactly is done. I would say always redefine the is equal in IFO. So that will make your life easier. Okay. And then, so now let's review. You must have remembered from your 2030, the OOP course, how do you define equality for Java, right? So let's say for birthday over here, let's say for the birthday class, we got month and day. And now for the equals method, it's going to be objects again. So now you can see these are the things you got to do. First of all, compare the references to make sure object is actually not null. And also, this is the part that's kind of a mystery, maybe still to some of you, or maybe have forgotten the details. Because this is object over here, so you have to make sure in order for you to say call month and also day, you have to cast this particular object type to the birthday type. But in order to cast it, you have to make sure this.get class, in this case, presumably it would just be birthday. And also object.get class, they should be dynamically the same so that you can do a cast over here. So this is the cast you do in order to call the month and day, the birthday specific attributes or method over here. So that's why over here you can say return this the month, this the day, other the month, other the day, right? It's a very quick review of what you have to do in Java. If you got any trouble, you can speak to me or you have to review your notes. I'm not going to say too many details, but the main thing to note is in the Java version, you will have to worry about this particular cast over here. So that's the main thing I want to point out first. Okay. Let's see the IFO version here. You don't need to do any cast at all. It's thanks to the use of the anchor type. Let's see exactly how that works. It's quite a straightforward idea. So first of all, like is actually a keyword in IFO. Like over here. And then it's going to be followed by some variable name. So that means the type for other is going to anchor. Is going to be an anchor. Whatever type it is for the current. Okay, current is the current class. In this case, current is really referring to any. Depending on where you say like current. If you say like current in the person class, it will be referring to person. If you say like current in the bank account class, then that will be bank account. If you say like current in birthday, you will be referring to birthday. So like current here really depends on what the current class is. So it's not really always the same. It's not a constant. Whereas when you say object over here, it's always a constant. Okay. So now in the birthday class over here for the IFO side, so we still got month and day. So here we simply copy and pasted the header, right? So now like current over here, so now current has been changed to birthday. So now it's as if over here when you say like current, it's as if we say other would be birthday over here. It's guaranteed by the compiler. Okay, So now when we know that it's actually birthday, we definitely don't have to do things like the cast over here. We don't need to do it like in Java. So what we can do is we can now focus on the design for the equality between birthdays. So we can directly say current the month, and other over here is already known to be of type birthday. So we don't have to use like a this.get class and also object.get class anymore, like in the case of Java. Okay, it's a very quick explanation about like current. So you should really know at least how to read it. Again, whenever you see the keyword like, so that means whatever variable that follows, depending on what its type is going to be the value for this entire expression. Okay, so like current over here, the expression value would just be any. So it's as if we declare other is of type any, and like current over here, the value will be birthday, the current class. So it's as if we declare other is of type birthday. Okay. We're gonna see anchor type possibly either in later tutorial or throughout the course. So I would say at this point, at least to understand how the anchor type is used in this very first example, especially how to use anchor type for is equal query.